In this video, I wanted to offer some strategies for looking at quadratic surfaces or functions for the quadratic surfaces, and then being able to pick out their key features and then maybe matching them to each of their graphs. So I have a list of functions here for quadratic surfaces and then some of the respective pictures that are related to those. And we're going to go through and match these and highlight key features. So our first function here, x squared plus y squared plus z squared, is this is actually going to be matching to a sphere. And the reason that we know this is because it kind of looks like the equation that we would have for a circle, except it's got a third dimension, which means that we're looking at basically a 3D circle, which would then be a sphere. And in particular, this one is going to have radius equal to 2. And so that means that this one is going to match to letter A. And this is really closely related to something that isn't drawn here called the ellipsoid, which I guess I could draw this over here. Like so. And this has the equation x squared over a squared plus y squared over b squared plus z squared over c squared, and that's all equal to 1. And the way that we identify this as being an ellipsoid as opposed to a sphere is that notice that it does still have the x squared, y squared, and z squared, where all of those terms are added together. None of them are being subtracted or anything. But now we're dividing by a, b, and c, which are different numbers applied to each of the x, y, and the z. And applying these different numbers in the x, the y, and the z scaling is what causes the ellipsoid to have a squished appearance instead of the round, the perfectly round appearance that the sphere has. So that's one way that you can tell a sphere versus an ellipsoid. They're very, very similar. The equations are in appearance, but you're going to see this kind of squishing effect in the ellipsoid that's due to each of these different coefficients that you see here. Whereas the sphere, typically you'll see a coefficient of 1 in front of the x squared, y squared, and the z squared. So, yeah, and I guess I'll label this. This is called the ellipsoid. All right, so our next one here, the z equals square root of x squared plus y squared. So how do we pick some main features out of this? Well, maybe kind of think back to the idea of square root of x squared. That's equal to the absolute value of x. And then we can also kind of pick out the idea of the square root of y squared, which is the absolute value of y. Now, these two pieces aren't what this exactly breaks down to, because we can't take a square root and split it into two pieces that are added together like that. But we do expect to kind of see these two main features in our graph or in our equation. And the graph of the absolute value is going to look like an upward facing a V. And so we're going to expect to see a V shape in our graph that corresponds to this particular function here, z equals square root of x squared plus y squared. The only two that meet that criteria are going to be B and C. But one thing to note is that the absolute value always opens upward. It's always going to be positive. So we're really just going to be looking at B there because C has both an upward facing and a downward facing part. So that one corresponds to B. Now, if we look at the z equals x squared plus y squared, we can think about this as two parabolas that have been added together because the z doesn't have a squared on it, so we're not going to get a sphere out of it or anything like that. But the x squared and the y squared tell us that we kind of expect to see maybe some parabola shapes in both of these directions. And the only picture here that has parabolas that open upward, because both of those are positive there as well, the x squared and the y squared are both positive, is going to be letter D, because we can kind of see that there's a parabola that opens upward in that direction. And then also, if we think about it as kind of wrapping around back to front like that, there's a parabola in that direction as well. So that's going to correspond to letter D. Now our next one looks really, really similar, except now we have a z squared here. But again, this can't wind up being a sphere because the z squared is on the opposite side of the equal sign as what it was from the equation for the sphere. So one way that we can kind of deal with this is rearrange, take the square root of both sides, making sure to note that when we're solving that we always use plus or minus on the square root. Well, now this looks exactly the same as what we had here with the z equals square root of x squared plus y squared, except now we have both a positive and a negative component. So what this means is that we're going to expect it to have the same shape of b, but have one that opens upward and one that opens downward, which means that we're going to be looking at c. Our next one, again, looks very, very similar, except now we have this plus 4 here. And we can apply the same idea of rearranging a little bit. And I'm just going to take z squared is equal to x squared plus y squared, and then I'm going to subtract that 4 off. And sometimes it's really helpful when we're trying to identify what's going on here to imagine what happens when we plug in specific values for x and y. If we plug in x equal to 0 and y equal to 0, this is going to give us z squared is equal to -4, okay? And, well, we can't take a number, square it, and expect to get a negative number out of it, which means that we're going to be looking for something that never allows x to be equal to 0 and y to be equal to 0, okay? We want to avoid these. And if we kind of look back at our graphs, E looks like it could be a possibility because it kind of has that gap there in the middle, and then F is another possibility. And if we look at both of these, E allows us to creep in toward the middle there, and that would be x equal to 0, y equal to 0, right? But if we look at F, we get stuck right here. This is the farthest inward that x and y come. So this doesn't really ever allow x to be equal to 0 or y to be equal to 0. So in this case right here, we're going to wind up with this guy being the letter F. Now, z squared equals x squared plus y squared equal plus 4 is really quite similar, same idea, except now we have that plus 4 instead of the -4. And so what that means if we take x equals 0 and y equal to 0, we wind up with z squared equals to 4. And that's really about as small as z is going to be able to wind up being, because we can't really introduce anything that's going to allow it to decrease from that, because we're always adding positive numbers here and here. And the only one that has kind of like a restriction on what z is actually allowed to be is going to be E, because we kind of have this gap here in the middle, which means that z can't be can't fulfill any of these values here. So that's going to correspond to E because of that break. So I want to highlight that these three right here, C, F, and E, and then that z squared equals x squared plus y squared, z squared plus 4 equals x squared plus y squared, and then z squared equals x squared plus y squared plus 4, those are all related. And the first one is a cone, or the double cone, and then F is what is called a hyperboloid of 1 sheet, and then E is what is called a hyperboloid of 2 sheets. And they all are related in how this constant that we add here changes. You can think about this as having a +0 on it. And I've included a link in the comments that kind of display visually how these all related when you change the constant that you're adding there. But they are all related. When it's equal to 0, you wind up with the perfect cone. And then when you add a positive number on the left-hand side, which is the same thing as a negative number on the right-hand side, you wind up with that hyperboloid of 1 sheet over here, which was F. And then if you add a positive number on the right-hand side, you wind up with that hyperboloid of 2 sheets, which is E. So again, take a look at the link that I included in the comments here. It's got a really, really nice diagram of how all of that is related and what happens when you change the value that you're adding there. Okay. So now we're on to z equals x squared plus y squared, and we're returning to this idea of paraboloids in the x and y, or parabolas in the x and y direction. Except unlike in letter D, we have that one is positive and one is negative. And so the plus x squared means that we expect a parabola opening upward in the x direction, And the minus y squared means that we expect a parabola opening downward in the y direction. And if we look back here at our graphs, I guess at this point we've eliminated A, B, C, D, E, and F. Well, we're looking at G and H, and really, I mean, honestly, even out of all of them, the only ones that show parabolas that open both upward and downward is going to be G. So see how we have one opening upward down that way, and there's also the same shape of them opening downward like that. So this one right here is going to be the letter G. And if you ever want kind of like a real life image of what G is, you can kind of think of this as being like a Pringle. It's Pringle shaped. Okay, finally, by process of elimination, we can say that our last one there is H. But let's talk a little bit about why that would have to be. So x squared plus y squared, this kind of looks like circles, okay? So you can expect circles. But because there's not a z involved here, like there was maybe back up here with d, we don't expect the size of the circles to depend on z. And so that's why we wind up with this cylinder shape where we have all of these circles that are kind of like stacked above each other is one way to think about it, that are all of exactly the same size, is because regardless of how high up we are on the function, we're always just going to wind up with the exact same circles, just repeated copies of a circle with radius equal to 2. So that's pretty much all there is to that. And but the key idea that you should be taking away from this is figuring out how to break down each one of these into individual little pieces, figuring out what you can expect based off of that. Like, for example, the the parabolas that open upward versus downward, like in letter G, and just trying to figure out how to put those individual pieces together to kind of gain an idea of what these must look like. So hopefully that'll be helpful in identifying these kinds of shapes in the future.